The shit is wicked on these mean streets. None of my friends speak. We all trying to win. But then again, maybe it's for the best though. Cause when they seeing too much, you...
Welcome to the video on the definition of the derivative. Okay, so in order to eventually get to what is a derivative, what we're going to do is start with the secant line. So start with secant line. Secant line. Okay, so on a graph, let's say we have something like this. Okay, so our x and our y axes. And then let's say we have some curve that looks like that. Okay, and this, let's say, is point P. I'll call that point P. And this is point Q. Okay, and point P, I'm going to say that has coordinates A and f of A. Okay, so A and the value of the function when you plug in A. And Q has the coordinates x and f of x. Okay, so those two coordinates there. And now let's look at the secant line. So secant line is basically the line through both of these points on the graph, right? So something like that. And so at this level, we're at f of A, right? And this is our A value. So that's A and f of A. And then this point here, that would be our x. So I already wrote the x there. And our f of x going across. So here's our f of x. Okay, so as you can see, if we make a triangle here to calculate the slope of the tangent line, of the secant line, we're on the secant line. So slope of the secant line, slope of secant line is going to be equal to the rise over the run, right? So rise over run is how you calculate any kind of slope. So what is the rise? How much does it go up? So that difference is going to be the top minus the bottom, so f of x minus f of a. Okay, so we'll write that on the top, f of x minus f of a. So that's how the difference in the y values, or in the function values, f of x, or the difference between f of x and f of a. Okay, and then what's the run? How much is this in here? So that would just be our x minus a. Okay, so x minus a. All right, so this is a good start. This is basically saying on the top here we had our change in f, change in the value of the function at given points, and then on the bottom we have our change in the x value. Okay, so something like that. Now let's observe what happens. So given all of this, so taking all of this into consideration, what happens when x approaches a? Sorry, that's supposed to be an a. That's supposed to be all dramatic. Okay, so as x approaches A. So basically, as x moves closer and closer to A, what happens? So we'll go over this on the next slide. So if we do that, let's say, again, we're going to start with, here's our x and y, and here's our graph. Here's P. P is going to stay the same, okay? Q is the one that's going to change. So here's Q all the way over there. And here's our secant line, right? So now we're going to make x go closer to, so here's A, and here's x. This x is showing you that we're on the x-axis. Okay, so here's x and there's a, and what if x is going to move closer? Let's see how it progressively gets. So here's x and y, here's our curve, okay, here's p. P is going to stay in the same point, so we're still at a, but now I'm going to move my x closer. So instead of here, I'll move it here. Okay, so here's x, so we're going to move our q there. Alright, so now our secant line looks a little bit different, right? The slope is definitely different. It's a little bit less steep, okay? So let's keep going. Let's see what's going to happen. So here's like the first stage. The second stage, we're going to move it closer. Number 3, the third picture is going to look like x and y. And we have our curve here. Here's point P. Okay, there's A. And now instead of here, I'm going to move my x even closer. So here's x, all right? So there's our new point Q. Now let's keep drawing the secant line, okay? So that looks a little bit, it's kind of the same, right, as number 2. But now, I'm going to move it even closer so that the x is literally, or almost, or virtually, on top of the a value, okay? So here's the curve, all right? So there's P, okay? And this is our value a. So x is like right here. It's like right next to it, okay? So then we have something that looks like that, all right? And this doesn't look so much like a secant line anymore as it does a tangent line, okay? So what we can observe is that as x approaches a, okay, so as it gets closer to our a value, then the secant line approaches or gets closer to the tangent line, tangent line. Okay? So, what does this mean? So, as the secant line gets closer to the tangent line, that means that the slope of the secant, respectively, so slope of secant gets closer to or approaches the slope of the tangent line. Slope of tangent line. And I'll add in a line here. Secant line and tangent line. Okay? So, this happens as x approaches a. Okay? So, here we're going to have one definition of the derivative, because there are a couple. So, the first definition of the derivative, so this derivative here, so f prime of a, the derivative of f evaluated at a, is going to be equal to the limit as x approaches a, so as x is getting closer to a, of the slope of the secant line. Okay? Because we know now that this slope of the secant line as x approaches a is going to approximately be the slope of the tangent line. It's going to get closer and closer and closer. So that is how the right side here comes to equal the left side, which is the derivative at a. Okay? So this is the first definition of the derivative. So definition number 1. Now let's go over another way of writing the derivative. So let's go back to our picture. Okay? So we're going to go back to our graph here. Here's our y and our x. Then I'll make our p and q. Like that. Okay? So here's p, let's say, and again, here's q. So we're going to start off far away. So this is going to be a, and then this will be our f of a. Okay? But this time, q, I'm not going to name it x, f of x. So we have our p being a, f of a. Okay? And now q, though, I don't want to name it using x's. I'm going to name that instead using how far is it away from a. So as far as the x value goes, I'm going to call it a plus h, where h is the distance, the distance in the x value, so the run part. So this length here is h, okay? So our q, our x coordinate is going to be a plus h already, okay? So that's a little bit different than x, right? This is just a difference in naming things, and therefore the y value, or the function value at that point, is going to be f of a plus h, because we're going to plug it in there, okay? Alright, so then we have an f of a plus h. Okay, so now if we try to do the same thing, we're going to do the rise over the run. So here's the rise, and this is going to be f of a plus h minus the lower one. So we're going to do top minus bottom, f of a, okay? And then the bottom is just going to be, it's h, but it's actually a plus h minus a. So a plus h. Sorry, that's an H. That was a really weird H. A plus H, there we go, minus an A, which turns out just to be H, okay? So if we try to find the slope, let's find the slope here. Let me draw that line through. Okay, so here's our secant line. So slope of secant, because we're still dealing with the secant line, is equal to f of a plus h minus f of a. Again, this is the rise. This is how much we changed in the y direction. And then we have an a plus h minus a on the bottom, which is the same thing as an h, okay? Because the a's cancel out. All right, so now what are we going to approximate? Like as x goes to what? Or what's happening here? So basically what we want is for this point, our a plus h value, our x value, to move closer to our a, okay? So we want that to move closer. So that means that we want to minimize our h value, the distance in the run, okay? So if we are minimizing our h value, we want it to go to 0. We want it to be virtually nothing, okay? So if h is virtually 0, this is what that would look like. So we have our p value, right? P value just stays there. That's our a. And then if our a plus h, then if our h is 0 or almost 0, it would be very tiny, or a very tiny difference in between, and it would look almost like our tangent line, right? So get closer and closer to our tangent line as h goes to 0. Okay, so using this definition of the derivative, just this way of naming things, so these points up here to calculate the slope of our secant line. So a way to name the derivative or define the derivative in this sense is f of a, f prime of a, is going to be equal to the limit as h approaches 0, so as the difference in the run approaches 0, of And then we're just going to plug this guy in, the slope of the secant line. So f of a plus h minus f of a over h. Okay? Alright, so this is going to be another, like I said, the second definition of the derivative. Okay, and this again is just another way of naming things.
Building blocks, now we fight for blocks with builders that make a killing. The closest of friends when we first started, but grew apart as the money grew and soon grew black.